Good morning, good afternoon, close, about noon. Good afternoon. Good afternoon or morning? I'm not sure which. First of all, thanks for having us. As Carly mentioned, my name is Chris Buff, and I am with Holman & Barnard. Who knows H&B? I know you do. Okay. For those who aren't as familiar, we are longtime manufacturers of all kinds of masonry accessory products. Everything from wire reinforcement to masonry veneer anchors to control expansion joint products to through-wall flashings to air vapor barriers. Pretty much everything that's probably mentioned behind that masonry veneer is what we're involved in. Company established in 1933, so as the insurance commercial says, we've seen a thing or two, but things continually change as well. My role with the company, I am Director of Architectural Services. So I primarily work with architects, structural engineers, building envelope consultants, those types. Hopefully trying to get things right up front before we get out on the job site and try to avoid some of the pitfalls that I see out there. So we'll talk through some of that. Been in the masonry world about 33 years. Actually, Labor Day will be 33 years. Was an independent manufacturer's rep for a number of years, principal at a firm, and worked for a national company involved in the masonry business as well before coming to Holman & Barnard, which I've been here close to 15 years now. So if you got questions as we go through, I prefer interactive. I do a lot of these, so it's actually kind of nice to get questions and maybe veer off topic a little bit. That's fine. I don't mind that at all. So title of the program today, Sustainability in Masonry Construction. You see the complete masonry wall in the title, and I added that to the title a couple of years ago. The reason I did that was I was getting more and more calls from architects asking me how we can create a system for the masonry wall assembly. What we've done in the past is we've taken a number of different products, and there's quite a few products going into that masonry wall. And we've taken those products from a number of different manufacturers, and we've put them together in the wall assembly. What that's created, and I know you guys are well aware of how exterior walls and envelopes of buildings are being scrutinized today, what that's led to is questions about compatibility of products that touch one another. Will one product stick to another? Will they work together? Are they constructible? All those things. So we see the masonry industry moving toward that system approach, and we're trying to embrace that as a company as well. This is an AIA program, and I am going to need to get this passed around. I'll start one over here. Start on this end. If you could get your name and if you got an AIA number on there, I'd appreciate that. It's a health, safety, and welfare credit. What we're going to talk about today are general design methods for masonry construction, and predominantly I want to talk about what's new, what's going on in our industry. Okay? There's a lot of changes going on. We're also going to talk about some of the things that we see moving into the future as well, and there's going to continue to be changes that are going to take place. We'll talk about different anchoring systems depending on what type of substrate you have. We'll also get into flashing, drainage, and moisture control, and then talking about those air barriers in the wall assembly as well. Just so everybody's aware, any metal product that I show you today is made of recycled content. So typical product is carbon steel with a galvanized coating on it. Those products have around 95% recycled content. So if you're doing a leaf project especially, believe it or not, these little component pieces can actually contribute, okay? From the sustainability standpoint, obviously masonry is going to last a long, long time. These little component parts are probably more important today than they've ever been, okay? And we'll talk about why that is. One of the things that I see in general, and this is a broad brush statement, is that we don't take into account the changes we're making in our wall assemblies with some of these component parts, okay? And what I see too often is we're cutting and pasting from projects from back, and all of a sudden the anchor that we're using on this project that was back here doesn't work over here. And so that's one of the concerns that we have today. H&B has 11 manufacturing locations across North America, and lead information is on our website as well. So what we have today typically is some type of a backup wall system, whether it's CMU, concrete, metal, wood stud. Typically, we're putting some type of a barrier on that backup wall, whether it's the concrete or block or sheathing or stud application. Continuous outboard insulation, airspace between the face of that brick and the face of that insulation and the back side of the brick. We have through wall flashing, drainage, termination bars. All these things are all component parts of that masonry wall assembly. So we have problems that we deal with masonry walls, and a couple that I've seen over the years. One of those is building movement and handling that movement through the use of control and expansion joints. I call them control joints. Some people call them expansion joints. It's terminology. We're really talking about the same thing. First question of the day. According to the Brick Industry Association, recommended maximum vertical control joint spacing in a brick veneer. 30, 25. It's between 20 and 25 in brick. Okay, in block it can be more. It can be more in block. Okay, but it's the recommendation is somewhere between 20 and 25 in brick. Second part of the question, more of an opinion. That is, where's the most important control joint in brick located? Corners, absolutely. Outside corners especially. What can happen is that if we don't have a joint that handles that movement near an outside corner, clay-based brick's going to grow over time. And what can happen is that brick, if the joint's not there, the brick will actually push against itself and potentially bow itself outward. I've seen that occur. I've been on projects where the brick has actually bowed so far that it separated itself from the tie. And then what you're doing is you're rebuilding the corner. Yes.
I was going to argue windows.
Those are the two big ones. It's corners and windows. One of those two. Absolutely. Yep. Second point is efflorescence. We've all seen that white salty mineral deposit on the surface of masonry, typically caused by excessive moisture of one form or another. Okay. Either moisture that gets in and gets trapped and we don't get it out efficiently. That's really more of the bigger culprit that we see where we trap moisture in that wall. Two things we're trying to do today to minimize that problem. Number one is we create that airspace behind the brick veneer. Anybody know the code minimum for the thickness of that airspace behind a brick veneer, masonry veneer? It used to. It doesn't anymore, actually. Well, the code does. Actually, it does because the industry changed too.
1 inch.
Code is 1. Industry recommendation. 2. Right. And that used to be 1 if you had insulation there. Now the industry's saying 2 everywhere. Yeah. That's a recent change, fairly recent change. I'm here to tell you 1 inch doesn't work. Okay. We've done enough in-house testing at H&B, and I'm in charge of all of our testing programs. We've tested 1 inch airspaces. They get clogged too easily. What happens is in those airspaces, especially with the 1 inch airspace, mason lays a bed of mortar down, sets the next brick down into the mortar oozes out of both sides, right? Obviously, they're going to come along with their trowel and swipe the excess off the outside. What they're supposed to do is reach in and swipe out the excess on the inside. You can imagine if you only got an inch, it's not easy to do, right? So guys just kind of ignore it. So that mortar now can bridge across from the backside of that brick potentially to your insulation. And now you got the possibility of a blockage in the wall, okay? So I always recommend 1.5 inches as a minimum. Again, 2 inches is the recommendation of the industry.
Quick question for
Yeah.
Mm-hmm. I've been dealing with that in my previous project. What are your recommendations with regards to having airspace and a non-airspace to avoid insurances? Like, for example, like a wall that's a gate or a retaining wall. Sometimes you want that to be just a single window with they call it. Then after a few months, you have efflorescence.
And
what are the cardinal rules that you?
I still believe, and And that's a good question, because where we see a lot of efflorescence is on those types of retaining walls and things like that. I still believe there should be an airspace, okay?
But like, for example, like, for a 4x4 pier, typically you don't have that issue, but for a gate or a retaining wall that's over 5 feet and 6 feet tall, then you see that evidence.
Right, and a lot of it depends on how you're capping the top of that retaining wall. I mean, if you're using some kind of stone cap, and you know, I mean, I've always been of the opinion that any joint in the vertical top of a retaining wall should be caulked. They should not be used. Mortar joints should not be used there, just because of the fact that mortar is going to break down, especially if water is laying on it. They should be caulked joints. That's where a lot of the moisture comes in many cases. And the problem is, with no airspace, now your moisture, if it can get through the cap somehow and get down in your wall, it's almost trapped in there and it can't get out. So I mean, I like to treat them just like a regular cavity wall, with airspace, with a flashing and a weep and everything else, and drainage, just like you would a regular wall. But yeah, good question. Yeah, it's a good question. It is. It is. Right. I mean, I ask like consultants and things. The other question that comes up is, what about sealers on the face on the face of masonry? And again, there's varied opinions, you know, but typically, especially in new construction where you can have that cavity, I don't think that sealers are worthwhile. You got your drainage, everything else. What you're talking about is like a composite or a mass wall. And they've worked for years, right? They worked for years. It's hard to say. So rusting of steel components, here's a wall assembly, a outside corner location. The workmanship's bad. The flashing that you see here is old PVC flashing. We used to use it in our industry. Probably some of us remember PVC flashing, but the reason we don't use it anymore, that's deterioration of the flashing membrane, okay? The building was 5 years old at the time the picture was taken, okay? So what happened here was, this decision was made, we're gonna remove a couple courses of brick, we're gonna brace that veneer up above there and come in and pull flashings. You see the shelf angle, relieving angle has started to rust. We're gonna take those out and we're gonna replace everything and do it correctly, okay? This was a 4-story hospital project, Allentown, Pennsylvania. 10 years ago, 12 years ago, maybe now. Cost per lineal foot to do that. Take a guess. Cost per lineal foot, $150. You'd have got the job, Bob. You'd have got the job. This one ran just about $250. Okay. We've heard numbers on high-rise projects as high as $500 a foot. So it gets very expensive to fix after the fact. So we're going to talk anchor systems of all kinds. The common functions of every anchor system is they got to provide the connection, and they got to provide the proper connection. And the reason, and I keep saying I'm going to do this, and I haven't done it, is I need to put that little arrow in there, that little red arrow, and say proper connection. The reason is because today that brick veneer is sitting further away from the structure than it ever has, right? Doesn't matter whether it's stud, CMU, concrete, whatever. We're putting insulation in there. We're asking for that 2 inches of airspace. I mean, I don't know what you guys are seeing insulation-wise, but I'm seeing some crazy stuff with amounts of insulation and wall assembly. So with that, we got to make sure that the anchor system is going to function and work properly. Transferring lateral loads, any stresses that the veneer faces. Okay, and it will face some wind loads, some other stresses. The anchor is supposed to take those loads and transfer it through the anchor and get it back to your structure where your structure can deal with it. Then we get into the ability to handle differential movement. Okay, can occur in all instances. This is probably the most extreme instance where you got cementitious block, which wants to shrink. You got clay-based brick, which wants to grow. So they're moving opposite of one another. And now you got your insulation, you got more insulation, more airspace, and you can imagine what's going on. This movement topic is one of the big ones in our industry today. 10 anchors deal with the movement that are necessary. They got to function with that continuous oscillation, and you also have air barrier interface. Okay, got one of two scenarios primarily. Okay, first scenario, if you were doing block, these little wires are coming through your block, a pair of wires every 16 inches, right, all the way around your building. So the air barrier's got to seal around every single one of those wires. Second scenario, probably a little more common for you, would be stud back up with sheathing. We put the barrier on the wall, everything is great, right? No matter what the veneer is, we're going to come back and we're going to start poking holes through, right? So those anchors need to be able to work in conjunction with the air barrier to make sure that everything, the air barrier is going to maintain its continuity and do what it's supposed to do. Do you do much block? Not. Should I skip through this pretty quick? All right, let me just go through this. There is one or two slides I do want to stop at. This one. Finishes, and this goes for all of our products, okay? Obviously, uncoated metal doesn't meet any codes. Mill galvanized would only apply really to wire anyway, which is, the mill galvanized is only recommended for interior work. The typical product is hot dip galvanized. Okay, so we take a product, we bend it, we shape it, we weld it, or do whatever we're going to do with it, and then we send it somewhere and they dip it into galvanized. Okay, and that's what it is. That's a product that's typical. That's what we recommend for exterior masonry. If you want to go a step further, you go to stainless. Okay, what does that mean? Two things. It means double the price, double the lifespan in round figures. Okay, the galvanized products are considered a 50-year product or so in our industry. The stainless is a life of the building product, 100-year product. Okay, but you pay for that. We are seeing more and more and more stainless. It's the fastest growing segment of our business today. It really is. I'm going to buzz through this, and we'll get to metal stud. Okay. First slide. It works. 18 gauge minimum metal studs for exterior walls. Now the new terminology is 43 mils or 0.0428 inches. And they color code these studs now, so even the dummies can look at it and figure it out, right? Okay. The reason this is, and I put this slide in because I kind of asked this question of a couple firms that I was talking to, and I got a few blank looks, okay? So I thought, well, maybe I'm just going to incorporate it into my program. The 18 gauge is important because, and you know, with the way that they can crimp and do things with studs today, they can get the strengths that they need with maybe a 20 gauge stud or even a 22 gauge stud. The problem is that our screws that go into that stud need enough there to bite onto, okay? And I learned that the hard way when I started with H&B, and we did some testing with some anchors, and one of the guys said, 20 gauge studs okay? And I said, yeah, I guess that's fine. And when we did negative loading, outward pressure, it actually pulled the screw out of the stud. Okay, so you got to have 18 gauge just for that purpose.
Why do you need the G90?
Why? Yeah, I don't know. Honestly, don't know. So 3 anchor types I'm going to show you. The first one is basically a 6-inch metal plate that has a slot cut in it to accept a triangular brick tie. The legs on the back are designed to go through your insulation, through your air barrier, through your sheathing, and the tips of these legs are actually designed to go back and touch the stud. That's to transfer that load that we talked about earlier, okay? A lot of vertical adjustability, which is important today, okay? So that if joints don't line up exactly and things aren't working exactly the way you want, there's some give there, okay? So that the contractor can make it work in the field. This product is what I call a post-installed anchor, meaning that it gets installed after the installation's done, okay? The positive to that is 4x8 sheets of insulation, up the wall faster, okay? I don't know if you do this at all or not, but I'm getting more and more firms that are specifying for the joints on the insulation board to be taped or caulked or sealed in some way. Okay. The reason being is there's been a lot of studies done that basically have shown that if you can have even a tiny little gap between boards, rigid insulation boards, and air can get in there, it can affect the R value, the effective R value of that insulation. Okay. So that's the advantage to installing after the insulation's up. What do you think the disadvantage is to installing after the insulation's up? Hitting the stud, right? Hit and miss. Yeah, hit and miss. So that's the give and take, okay? But I will say, and I have another post-installed anchor I want to show you, but we see more post-installed anchors. The other thing that I like about the post-installed anchors is these legs are made specifically to the length depending on how much insulation you have. So now what happens is, as this goes in, that plate's holding your insulation tight up against your substrate, which is another good thing, so that we don't get airflow going behind your insulation board, which again can cause you some R value in that board. Second anchor is a pre-install. It's a very simple L-shaped bracket. Okay, vertical leg onto your sheathing or your air barrier. Horizontal leg varies in length depending upon how much insulation you got. And then the hook or the pintle, the legs go in here, and this goes into your brick joint. Okay. How far is a brick tie supposed to go into the back side of the joint by code? Anybody know? 1.5. Good. Now see if you can get the second. No closer than from the face. There you go. Got it. Okay, so in a nominal 4-inch brick, you got about 2 inches of play to get it in there properly. I talked about adjustability earlier. Okay, that's what I'm talking about. We can actually move these legs up and down to get it to line up with the brick joint. You can install these upside down. Okay. This is the standard product, gives you 1.25 inches of adjustability, and from that center point. This is the high strength pintle because it's a heavier gauge. Now we can make the legs longer and give you more adjustability if you need it. And I get that call, I'd say once a month, where an architect's calling me and saying, "Hey Chris, I got standard brick, I got modular brick, I got a decorative 8-inch block band running through my wall, and I'm trying to course this out and it's not working, and I'm off 1.5 inches or 2 inches. What can I do?" Well, there's ways to deal with that. Okay, and we actually have anchors that can embed into your backup wall and have a vertical rod that you can take the brick tie and slide it up and down wherever it needs to go. So there are ways to accomplish that. Third tie is the fastest growing tie that we have, and that is a barrel type anchor. Okay, the makeup of the anchor, you have your screw type, depending on what your substrate is. You have a section here, a small shoulder section that represents the thickness of your sheathing. So 1/2 or 5/8. I don't know how well you can see it. There's a little rubber gasket right at the outside face of that section. Okay, that gasket is there because that would line up typically with your air barrier. So as this penetrates through the barrier, that gasket's helping to seal that penetration. Whatever thickness of insulation you have, larger gasket out here, seal at the face of the rigid. Okay, again, all these are sized, so this is going to be holding that insulation tight up against your substrate. Okay, very, very popular. You can imagine this is 2 screws. We recommend a piece of tape to help to seal. Okay, basically here everything's built in. So you get a little chuck that we sell the chucks that fit onto there. You shoot it in one time, you're done. Okay, so much less likely to miss studs with this versus the legs of that other product. Who's dealt with thermal transfer? We've talked about thermal transfer, right? Everybody. Okay. This all kind of occurred about 3 years ago, and I travel all over the country. Well, this will tell you. I'm speaking to a firm in Seattle, Washington, and we got started talking about the energy code. And I made the comment that masonry ties, you don't have to calculate them into, when you do a U-value calculation, well, if you're doing U-value, of your wall assembly, okay? Guy in the back of the room raises his hand and he goes, hey, Chris, you're wrong. And I said, what do you mean? He said, oh, here in the beautiful city of Seattle, and now the state of Washington, you must calculate into your U-value anything that penetrates the continuous insulation layer, including masonry anchors. And I said, really? He said, yep. I said, how do you do that? And the whole room started busting out laughing. They said, we have no idea. We thought you were coming to help us. We don't have any idea how to calculate it, okay? So I said, well, sorry, I'm not your man. I don't have those answers. So I came back east, called my boss, and I said, hey, we need to do a little research here, okay? Because I had actually gotten another call or two regarding the same thing. So two things we learned, and one of the questions that I'll ask you is, we deal in three metals. We deal in zinc, carbon steel, and stainless steel. Which one of those three metals do you think is the least thermally conductive? Zinc, carbon, or stainless? Zinc's the worst. Carbon's right below it. Stainless is way down here. Okay? Stainless conducts 1/7 the amount that zinc does. Okay? So, second anchor, off of the same theme, we changed the barrel to stainless. We knew it was going to be better. Okay? Second thing we did was, up top, we made a change, and we created a wing. Okay, this wing has steel on the inside, encapsulated with this high temperature UL94 plastic, with the idea that as these same pintle legs go through, we've broken metal-to-metal contact between the two to increase thermal performance. So, how well did we do, right? So we went to a lab, we asked if they would do some computer modeling for us. So what this is a 6-inch metal stud, 2 inches of rigid, 2 inches of air, nominal 4-inch brick veneer. Exterior temperature, 0. Interior temperature, 70. With the zinc barrel, those are the temperatures along the inside face of the stud. With the stainless barrel, those are the temperatures. When I saw that, my reaction was, wow, that's pretty big, right? So I know quite a few people in the envelope consulting business. So I took this information to them, and every single, I shouldn't say every single one, 90+% of them said to me, that's great, Chris, but I don't believe it. And I said, well, that was an independent lab. It wasn't us. It was an independent lab that did it. The next question was, is that 2D thermal modeling or is it 3D thermal modeling? I said, it's 2D. They go, oh, come on, Chris. 21st century, man. 3D. We need 3D. Back to my boss for more money. I put my right hand up when I tell you this. $140,000 later, we have 3D thermal modeled every single anchor we make. Okay? The 3D modeling confirmed this. I wouldn't say absolute positive 100%, but very, very close to that. But now what the 3D modeling did was it gave us the information that I can give that architect in Seattle who's putting 3 inches of rigid insulation in their wall and using any one of these anchors, doesn't matter which one, any one of them, I can give him a multiplier that says you're going to lose 0.000, whatever that number is, for every one of these. Multiply that times 40,000 of them that go into your exterior wall assembly and calculate that into your U value. Guess what? It's on its way. It's on its way. Okay? So if you do that modeling with the U value calculations, all I want you to know is we have the information. Okay? I don't think it's here yet, but it's coming. Okay? And we spent a lot of time and a lot of effort making sure that our anchors are as thermally efficient as possible. There were two things we learned. One thing was the type of metal, stainless the best. The second thing was, and I don't know how well you can see this, was, and this makes sense, the amount of insulation that you displace as you push something through the insulation, okay? So here is, that's the original size of our barrel. Now this is the stainless product, but I don't know how well you can see. But we shrunk the barrel size down. So we're displacing less insulation. We still have the strengths that we need. Again, we're all about trying to get this thermal performance of the anchor. You're gonna hear more and more about it as we continue to move forward. Second slide here is everything's exactly the same, except this is simulating 8-inch CMU as opposed to metal stud, and obviously CMU is not conducting like metal stud, so differences are less dramatic. Stone anchors of all kinds. Again, with all these systems, here's a question for you. What's the maximum total cavity size you're allowed to have by code? Face of structure. So if you're doing stud, right, it's the face of stud. So you got to count in the thickness of your sheathing into this number. Insulation, airspace to the backside of brick. So face of stud, the backside of brick, there is a maximum cavity size you're allowed to have by code. Anybody know? You did this, right? It's 4.5. It's 4.5. Okay. If you go over 4.5, what's supposed to happen is the anchoring system is supposed to be engineered specifically for your project. Okay. We have our own engineering department. We do a lot of that. We run the calculations. We stamp the numbers. We take the liability on when it gets into those situations. Don't just think about your wall. Think about maybe if you're corbelling brick, you're doing some different things with your brick where you're stepping it in and out, may put you into those situations. And what I would tell you is, hopefully everybody's got my card. I don't like to push that real hard. You know, there's a lot of situations where you go to maybe a 5-inch cavity, and I can look at it and say, it's not, you're okay, you're fine. We don't have to go through all the engineering. Okay, I try to minimize that as much as possible. You guys do some mid-rise, I don't know about high-rise, mid-rise stuff. Start getting into 4, 5, 6, 8 stories, we might want to start looking at that kind of stuff if you ever get there. Okay. All right, switching gears to moisture. Old study from the University of Maryland. Do we have any Maryland grads here? I'm in the territory. I'm going to bust your chops here a little bit. 90% of masonry problems attributed to moisture. I agree. Okay. Pie chart places the blame for the problem. You went 41%. Okay. I saw that number and it didn't strike me right away. I saw 16% construction related, and that's when I kind of went, oh, wait a second. Okay, who funded this study, right? So I don't know if I buy all this, but certainly moisture's our big issue, right? What causes problems? Joints that don't get filled, over-sanded, over-tooled, not a huge deal. Weep holes and vents clogged or omitted. I had a school district in Ohio that had leaks in their buildings and caulked the weep holes shut because they thought that's where the moisture was coming. A little bit of a problem, okay? Flashings, omitted, improperly installed, or poor quality material. For my money, it's improper installation of products, which sort of goes against the 16%, right? That's what I see as the biggest problem. And then protection during construction. Again, this is sort of out of your realm. This is more means and methods, but it's a big problem that I see in the industry. Think about what we're doing today. We're putting air barriers up. We're taping and sealing around windows and pipe penetrations. We're running flashings, and we're using sealants to tie all that stuff together. All those products need to be able to cure, right? I had a call from a contractor in Texas. Oh, this goes back a few months now. Says, hey, Chris, so we're using your air barrier, fluid applied, said, stuff's crap. I go, oh, yeah? I go, what's going on? He goes, I don't know, it's just running off the wall. That stuff's crap. I said, well, I've been on hundreds of air barrier jobs, and it's never just run off the wall. I said, tell me what's going on. I don't know. I don't know what's going on. So, well, Did it rain? Well, yeah. Well, how long after you installed the air barrier did it rain? Well, half an hour. So, and I know this is, again, out of your realm. This is a big problem I see in our business. And we're trying to do buildings, we're trying to build them and get them up and, you know, as fast as we possibly can. And sometimes we need to take some common sense approach to some of this stuff, okay? I guess that's all I'm trying to say. So, through all flashings, how we get that moisture out of those cavity walls. Product's got to be water resistant. All these things are things that you could consider and look at when you select flashing products for your project. The one for me is installability. How easy is the product to install? Again, this is kind of a common sense comment, but the easier it is to install, the better chance you have of a good installation. Simple as that, right? The industry has done, I think, a really good job of creating more and more and more easily installable flashing products than they did 15, 20 years ago. There's a lot more out there. What's the best flashing product on the market? No cost. I know.
Stainless steel.
Stainless steel, right? That's the best. Okay. Typically, stainless has been 24, 26 gauge pre-bent pieces of metal made off-site based on your drawings, shipped to the job site. They're rigid pieces of metal. Your buildings aren't always exactly as you draw them. I think we all know that. So now you got a contractor out there with a rigid piece of metal trying to get two to fit together and make it watertight, and he's got a ball peen hammer in his hand. And I'm going, oh, God. Right? So what we've done is now there are thinner gauge stainless products that are flexible. Okay? So now you install stainless just like you would a membrane flashing. Okay? You get the advantage of stainless, you get the advantage of easy installation, and I'm biased. This is the winner. This is the best product that we make. And we're not the only people making it. There's multiple people making this. It's the fastest growing flashing product that I've ever seen in my career. Okay? It's just got a lot of positives to it. It's also available in a self-adhere, so you can peel and stick stainless. On your wall. 36. Okay?
Megan Telford was through here like 18 months ago with her presentation. And
It's a great product. Yeah. There's probably 5 or 6 of us now that make that product. Okay. The other option, if you want to go metal, is copper laminates. Okay. 3, 5, 7 ounce copper. Historically, these have been coated with asphalt on both sides to protect the copper. Okay. Problem with asphalt. Most of the air barriers that are out there, so you guys using fluid applied? Sometimes?
started.
Okay. Fluid applied air barriers are 95+% non-asphalt. Let me know why. Let me hear of NFPA 285. You know what that is, right? Okay. Asphalt and NFPA 285 is basically a flammability test for a wall assembly. Okay, and asphalts are just too flammable, and they can't meet that test. So that's why most of the air barriers today are non-asphalt, so that they can meet that. Can you put an asphalt flashing up against a non-asphalt air barrier? The answer to that is no, you can't. Compatibility-wise, that's a problem. I'm on a committee at the Air Barrier Association of America, and we are putting together a chart right now of, and I'll show you a little sample of what it's going to look like. Air barriers across the top, different flashings down the side. You bring your two products together, and it's either a red, a yellow, or a green block. It tells you can do it or you can't do it. Okay. Essentially, what we're saying is, and what we're learning in the research is the oils in the asphalt okay? And do you want to take that risk? So this is going by the wayside, being replaced by this. Same sheet of copper, and now it has a piece of polyethylene sheeting, woven polyethylene on either side to protect it, okay? Same thing inside. So now we've eliminated asphalt, so now it can be used with those non-asphalt air barriers, and same thing with the copper. Make it peel and stick, okay? So that's available. Why do I like stainless over copper? 35% less cost. Yeah, 35% less in cost. In no circumstances should flashing be stopped behind the face of the brickwork. BIA Tech Note 7B. Translation. You better be using a drip plate. You use drip plates with your flashing systems. Yes. Amen. Okay? I got to tell you a quick story. I'm on a job at the University of Oklahoma. Big multi-building dormitory addition. They have this flashing specified, okay, correctly. When we use a drip plate, we always say hold the flashing back 1/2 to 3/4 of an inch from the face of the brick. So the face of the brick sits right on that edge of that lip, okay? So the representatives from the university come out, they look at the mock wall, they see that line, and they go, we don't like that. Take it out. Okay, take it out, right? Last thing that was said on the subject. I was already gone, so because I would have piped in at that point. So now they build the wall with this, held back 1/2 to 3/4 of an inch and no drip plate. And 3 months later, I get a phone call. Chris, we got 96 leaks in the building. 96 leaks. So I go out there and we start opening up walls. And it would have been great if it would have just been held back at 1/2 inch. There were areas where it was held back 1.5 inches, where the cores of the brick were open. Okay? So what they do, they routed out all the joints where the flashing was, and these were like 8-story buildings. Routed the mortar joint out all the way around, took a little piece of this, slid it underneath, brought it out to the face, and caulked that joint where the new piece and the old piece met. A little communication after that mock wall review would have eliminated that whole problem. Membrane flashings, EPDM, great material, right? UV resistant, flexible, all that good stuff. Compatible with next to nothing. Literally next to nothing, right? If you do an EPDM flat roof, single ply, Firestone, let's say, it's Firestone caulk, it's Firestone tape, it's Firestone adhesive, it's Firestone this, Firestone that. You can't just mix products with EPDM. Very, very sensitive to other products, okay? This should never, never, ever go against asphalt. Asphalt will eat this stuff, okay? I've seen it happen. So we don't see a lot of that because of those limitations. What we see a lot is rubberized asphalt flashing, okay? Peel and stick. Plastic, some type of polyethylene sheet on the surface, peel off the back, and you got adhesive on the back side. Typically, this adhesive has been asphalt. Let's go back to our study that we're doing, right? Asphalt up against non-asphalt. There's manufacturers that still make asphalt flashings and non-asphalt fluid applied air barriers, and they're getting themselves into a pickle with this whole thing that we're doing. We've been doing non-asphalt adhesives ever since I've been at H&B, which has been almost 15 years, okay? This is hot melt glue, a version of it, with some fillers, okay? So all the asphalt's out. This can go up on your non-asphalt air barrier, no problem. The other thing with asphalts is they melt, okay? The melting point of asphalt about 140 to 160. Believe me, your wall, your south-facing walls on a day like today can get there, This stuff melts at 300 degrees, okay? The other thing I see with asphalts, and I'm just pointing it out, I see staining with asphalts. And I see all that brick stuff, and then I see a piece of cast stone, and I just see that black in the cast stone. That's from the asphalt and the flashing. So we see the industry going away from asphalt. I think 3 to 5 years from now, you won't see any asphalt in the wall at all. There's also an alveoli membrane, which is a DuPont polymer that makes this membrane UV resistant. Okay, soft, flexible, UV resistant, like a roofing membrane, like a TPO. TPOs have the alveoli membrane or polymer in them with adhesive on the back. Okay, so this is like a higher end peel and stick. Could be exposed if it needed to be. So it's got some advantages there. The other thing is compatibility with silicone and urethane sealants. Do you think asphalt products are compatible with silicone and urethane sealants? Can't stick an asphalt. You can try. Okay, it's just not going to adhere very well. Even a silicone, which you think silicone sticks to everything. Try it with asphalt. Okay, so again, that's why we're slowly moving away from that. Preformed inside, outside corners and end dams made out of stainless and copper. There's other products that are available, but these are user friendly. Where do you flash your building? Top and bottom, anywhere in between where you stop the downward movement of moisture. Okay, flashing, termination bar, drip plate, drainage, the whole 9 yards. We believe strongly in term bars, mechanically attached. Okay, bead a sealant across the top edge of the term bar, and remember, we have an air barrier on this, right? So that bead of sealant has to be compatible with that. It needs to stick to that metal term bar, and it also needs to stick to whatever that air barrier is behind it, if it's going to do what it's supposed to do, right? The kiss of death, the worst thing that can possibly happen is moisture gets behind your flashing. Just guess which way it's going in, right? It only has one way to go. You can't get out. Drip plates of all kinds. Again, we have different options with drip plates. Here's a compressible foam that we use for certain applications, especially on a multi-story building where you are putting a stainless steel drip edge on a galvanized angle. 2 different metals, right? That's the separator between those 2 metals, so you don't get any galvanic reaction between the 2. Mortar collection devices. MortarNet made this product popular and famous, and now their patent ran out, so everybody makes it. It's literally half the price it was 3 or 4 years ago. Weeps and vents. Honeycomb plastic, this product here, that's what we sell the majority of. That fits into the head joint of your brick, okay? Gives you more room for moisture to escape, for air to get in, okay, than just these little tubes or cotton cords. The other thing is we're venting masonry walls now. Hope you guys are doing that too, where we're not only putting these at the bottom of the wall, we're putting them at the top of a section. So if you were doing multi-story and you had a shelf angle, we put a weep at the bottom of where your flashing line is. We put a vent at the top below your shelf angle, okay, and we're putting a weep at the flashing right above the shelf angle on the second floor. Okay, ventilation is a good thing. We've done testing of ventilated walls next to an unventilated wall, and I'm telling you, the moisture gets out of a ventilated wall faster, actually considerably faster. Ben, what time is it? I just want to. You guys have heard air barriers 100 times, right? 8 minutes. That's cool. That's fine. I don't want to bore you with this. Okay. I approach this very simply. Okay. There's 2 ways for hot, cold, and moisture to get through the envelope of your building. The first way is the blue lines, channel flow, which means there's a crack or a gap somewhere where air can shoot through the envelope of your building. Okay. Air carries 95% plus of hot, cold, and moisture through the envelope of your building. Second way are the red lines, which is diffusion, which means vapor that passes through the materials in your wall assembly. Vapor passes through everything, okay? It's not a whole lot. We're really more worried about air, right? So when we test barriers, okay, we test them at channel flow, meaning gaps and cracks, at pressure levels. And what I mean by that is warm, moist air always tries to get to cool, dry air. Okay, remember that. Warm, moist air to cool, dry air. So it's what, 95 out today? It's 70 in here, so the drive is inward. Okay, if it was 70 in here and it was 30 outside, the drive would be outward. Okay, the greater the pressure, the greater the difference between those two numbers, the greater the pressure. So we test at what we call positive and negative at 6 different pressure levels to make sure the barriers will do what they're supposed to do. 2 products. Breathable, permeable product. Stops air, allows vapor to pass through, allows your wall to breathe. If you are doing stud backup walls and you are putting insulation in the studs, you've got to have a permeable, breathable barrier. Okay? You have to. Well, I guess you don't have to, but you better. Okay? I see more and more firms taking that stud insulation out. I don't know if you guys are looking at that or not. I've seen a lot of firms that are taking that stud insulation out and putting everything outboard. The reason for that is because if you put everything outboard now, you know your dew point or your condensation point is outside of your interior wall assembly. You don't have to worry about it. Okay? Still, typically we see, I'm a big believer in permeable, breathable barriers. Okay? There are non-breathable barriers that are supposed to stop air and stop vapor and stop everything. The problem with those is, depending on if the pressure is going this way or that way, and depending on where your insulations are, you can get into a mess. Okay? So, you know, you're in a climate where we get today, and then what, January it could be 0, right? So you get both. That's why I believe the permeable barriers are becoming more and more popular all the time. Air Barrier Association of America, I mentioned, these are the 3 main tests for air barrier products. Then there's a whole series of other tests, individual product tests that we do as well. This is the key. How do we detail? Okay, door, window openings, pipe penetrations, anything penetrating through your wall, we got to detail it. Holman & Bernard has 3 detailing materials. We have a tape, we have 2 different liquid products. Depending on your application, one doesn't fit every application. We have 3 of them, okay? This is, and you're the kind of work that you do, this is extremely critical, because if you're doing mid-rise and it's condos or whatever, apartments, and you got windows all over the place. I was on a job in Hoboken, New Jersey. We just completed, I guess it was beginning of this year, 17-story high-rise condos, okay? They were using our tape system. Okay, it's peel and stick tape. Over 70,000 feet of tape on the job to detail all windows and pipes and everything. And I said to the contractor doing the job, I said, do you break down the cost to detail versus the cost to spray our barrier on the wall? He goes, yeah. And I said, when you get a chance, just look it up. I'd be curious to know what the breakdown is on this job. 85% of the cost of the job is detail. They were only spraying little sections, 6-foot sections in between window openings. Okay, this is where the problems are. It's not done correctly. So we're taking the barrier up the wall. Roof comes across. Can we stop there? Can we stop there? No. Say no, right? We got to tie those 2 together somehow. Okay, and what gets tricky sometimes is if this is non-asphalt and that's asphalt, that can get a little tricky. Okay, I deal with architect firms all the time on how we put that detail together. Anchors and barriers, we talked about that a little bit. Liquid versus sheet, you could use both. I would never use sheet on CMU. We got the little wires coming through. That's craziness. Okay. Train certified people installing barriers. Pre-installation meeting. I'm a big believer in pre-install meetings. You call me and say, hey, Chris, I got, you know, Let's hope here. We're using your air barrier, right? And we'd like you to be at this pre-install meeting. Okay, important job for us. We need this right. My first question to you is going to be, is the roofer going to be there? And if you tell me no, I'm gonna make up an excuse why I can't show up. I wouldn't do that, dude. Seriously, I wouldn't. But I want the roofer there because of that detail. It's the toughest detail, because sequencing of construction can change that detail. If you're building this first, or if you're building that first, could change that detail. Okay, that's one you got to get right. Compatibility of products, number one problem in my life. I'm the letter writer for our company. Ben can tell you. I write letters about compatibility every single day. Every day I write them. I have the templates, right? The yay and the nay. The yay is a great one. The nay is a problem. Here's what happens. Masonry, through wall flashings, Division 4, right? Air barriers, thermal and moisture protection, Division 7. In some cases, maybe many cases, I'm not sure in this market, those are two different contractors installing those products. They don't talk to each other. They don't give two you-know-whats about each other. They could care less. So the mason picks one of your flashings, stamp, approved, right? Air barrier guy picks one of your air barriers, stamped, approved. Everything goes in, GC has it, everything's great. We build a mock-up wall, and somebody goes, wait a second, that's asphalt, and that's not asphalt. What was that guy's name that told us we shouldn't be doing that? Okay, so then I get the phone call. We need a letter. I can't do it. They're not compatible, right? So now one of these two guys has to change. And oh God, it's a crisis at that point, right? And so this is always the 11th and a half hour that we're doing this. So my goal with every firm that I talk to is, let's get all that stuff right in the spec. Let's make sure that it's right so we don't deal with that. So I don't write as many letters, okay? I mean, it really is a big, big problem. Okay, I mean, I write multiple letters every day. It's the biggest issue in our industry. Lots of insulation in walls. Okay, here's a job up in Pennsylvania. You see the 4-inch brick. You see that job had 5, 6 inches of insulation. Okay, crazy, crazy, crazy stuff. They're outside of the code. All right, here's another one. Look at that corbelling. How do you like that? Right? You were involved in this one, right? It's Bucknell University, right? Okay. Look, arrow to nothing. Arrow to nothing, right? After we got our hands on this thing, look at that gap. I think that gap was 12 inches. Nobody thought about the anchors being, okay? So go ahead, ask me what we did. What did you do? Took the metal stud and angle it. Keep the cavity the same size. Yeah. It was the easiest answer by far. How about offset shelf angles? You heard about those at all? We talked about thermal, right, with our anchors and stuff. Now the next thing is, and this was voted on for code, it got voted down by 1 vote, so it's coming the next time. Taking that shelf angle and bracketing back to the structure, so that instead of this whole piece being up against your structure, transmitting, we're just contacting the structure with these brackets, and now your insulation goes behind the shelf angle. Okay, you'll see this one too. This is coming. All right, whether it's metal, steel structure. Here's concrete, where we use in the upper right. You see the expansion bolt. The one that I like is these embeds, so that now you can adjust these angles. Here's a way to adjust it up and down. You can adjust side to side. This bracket adjusts it in and out. Okay. It's something you'll see. It's just this is just an FYI, but something you will see. The reason this is happening, part of it is because we're putting so much insulation out there that these shelf angles are getting like pieces of structural steel. I mean, it's crazy how big they're getting. I mean, I was just involved in a job in New York where there were 7 inches of rigid insulation. The structure, the shelf angles were 10 by 10 by 5/8. 10 by 10 by 5/8. Okay. So now, yeah, it's a piece of structural steel. Yeah, it's a bent plate. So now, how do you maintain a 3/8 inch mortar, right? You got a 5/8 inch piece of steel, so now you're in the lip brick. If anybody knows what lip brick is, okay? And now you got that detail with the flashing and the lip brick, and okay? The nice thing about them is that angle will never change. The size of that angle will never change. Well, I shouldn't say that. Most likely, it's never going to change. Okay? It's just that bracket's going to change, depending on how much insulation you got. How do you flash that? Great question. It's going to have to come over. You're going to have to come across here and out and over top. Yeah, we're actually working on. This is brand new stuff. We're actually working on flashing details for this. I'm going to give this to Ben in a minute here. Ben, I got one more slide I want to show. This is our, and this is preliminary. It's not done, but this is the chart that we're doing for our Committee of the Air Barrier Association. So across the top, you see LAB means liquid applied barriers. Okay, so different types of liquid applied barriers, different types of flashings. And again, it's not 100%, but what you're seeing is asphalt, PVC is bad news anyway. You see asphalt here, you see asphalt here where we have the reds and the yellows. Okay, that's why we're moving back toward all that non-asphalt stuff. Okay, Ben, I'll throw this back to you for a second.
Yeah, and I'll make this brief, guys, because I know we're running out of time. But first off, just want to thank you all for taking the time. Special thanks to Chuck and Danny for helping set this up. Hope you enjoyed the presentation. What I like about it, Chris covers he touches on every little aspect of that cavity, and you get a sense of how much actually goes into it. That kind of leads me why I'm here today. As Carly mentioned in the beginning, I deal with the Masonry Accessory Division at Glengarry. I'm sure many of you are familiar with Glengarry through our bricks. See a lot of them on the pictures up here. The Masonry Accessory Division we rolled out about 10 years ago. The reason being that is we were working with masons every day, so we understood which products they were using effectively, which ones they preferred, and as Chris mentioned, a big buzzword, compatibility, which ones were compatible. When you're talking about that 3 to 8 inch cavity and there's 7 different manufacturers going in there, you got to make sure they're all compatible. So we took that knowledge, we went to the right manufacturers like Homan and Menard, you mentioned Megan at York, and we took that knowledge, and over the course of that time, we found ourselves in a good position to be a resource for you guys. So you'll see a couple things we'll do up here, specification reviews. We do that free of charge. We're promoters of masonry, so whether it's Glengarry brick or any brick, we want to see it go up correctly. So just send those over to us, we'll check them. Submittals, compatibility letters, as he mentioned, we'll help you do all that. The whole idea is this, save time on the front end so there's not that chaos on the back end. The masons we work with don't like putting in these RFIs, you guys don't like dealing with them, so our goal is to kind of make sure everything is compatible and good to go on the front end. In terms of that, I know Carly mentioned the brick, any future projects, keep Glengarry in mind, and definitely reach out. Our cards are on the table, and definitely hold on to Chris's because he is a great resource to have.
By the way, everybody, I don't sell anything. They do. I don't sell anything, okay? I'm just an information resource. That's all I do for our company. So there's direct phone numbers on my cards to me, email address. Please feel free to use me as a resource. Okay, you got a question on a masonry project, I think I'd encourage you to give me a call or shoot me an email. You got a detail you're not sure about how to work. I don't have all the answers, but with the people that we have at H&B, and we got a lot of people that have been in the masonry industry a long time, we can figure it out. So.
Thank you, guys.
Thanks.